The cat is like clawing her way onto the chair. I think she really wants to say hi. Okay. All right. Let me just get everything positioned here, and we'll get started. So, I've been talking a lot for a little while about how theoretically we could make Diesel literally faster than a SQL string because we can use the type identifier of the query as the cache key instead of having to hash the SQL string. This assumes, when I say faster than a SQL string, that you still want to have that level of abstraction where you have a function that you call and you give it a SQL query and then it goes and executes that query. If you're fine with having like knowledge of exactly how prepared statements work in your application leak throughout your entire code base, then you can probably beat this slightly. But anyway, so I think I'm not 100% sure if it's going to be feasible without specialization. But I think it's worth a shot. Now, for this to be a useful thing, we will need... There will still be a few types that we won't want to cache this way. We won't want to, we won't want to go through boxes or trade objects of any kind. And there's one other constraint here that I'm not sure if it's going to be a problem or not. Let me get this. So if we're going to get the type identifier as a compile time literal, we're going to end up calling this type ID of method or function, whatever. And it has this constraint where t is static, and that's just a constraint of any as well. I don't think that's a problem. We can't use type ID directly because the most important type here that what's the right way to put this? Not every piece of a query needs to change its SQL based on the type changing. The main one there is the AST node that represents a bind parameter. The left-hand side there is the SQL type, and the right-hand side is the actual value going into it. But, for example, if it's a bind param of type varchar, we don't care if we're putting in a str or an owned string. We can use the same prepared statement for that. So the type ID, or the ID of the bind parameter containing a left-hand side and a right-hand side will only vary based on the left-hand side. And the right-hand side is the only thing that wouldn't be static. And I'm not sure if we have anything else that wouldn't be static. And that's why I'm wondering if maybe we need specialization for this. But even actually, now that I'm saying this, specialization wouldn't help at all, because specialization doesn't let you specialize based on lifetimes. All this to say that we won't always be able to do this magic. We just know the query without having to do any work nonsense. But we can try to do it some of the time. So I don't know. Let's see if we can make it work or not. If I can quit Vim, the hardest problem in computer science. Make this reasonable sized. Okay. So I eventually want to move this to a different trait and maybe make it a super trait of a query fragment or something. But I'm going to go ahead and just put this method on query fragment to start. So this will be something like, I'll just call it query ID or something. And it does not need to take self, because we're not going to do anything with this for boxes. Or we're not going to do anything with this for trait objects. We'll return an option of a type ID. And because query fragment needs to be object safe, we'll add where self is sized. And I'm also going to give that a default implementation. Okay, so let me make sure I didn't do anything stupid that fails to compile there. And the package is not called reflect, it is called any. And we might need to separate out asking if it is asking if a type can use that static ID from. We might need to pull that out into a separate function of actually getting the. Maybe not. I'm just thinking, like, type ID isn't something that you can compose. If I've got a type like and, I can't get the type ID of the left side and then go combine that with the type ID of the right side. I just need to get the type ID of and left and right if the left-hand side is safe to do this with and the right-hand side is safe to do this with. But I guess we could still have this be the same function and just check that the left and right. You know what we can do? No, I can't do that default implementation because that would need to add the constraint where self is static, and I don't want to do that. All right, I'm worried that if I leave these as a single function, that it's too easy to forget to check the children, although I guess it's just as easy if I pull it into a different function. This is fine. So I just want to see if this actually even makes any noticeable cool difference. Mainly that SQLite benchmark that after yesterday was under was 1.1 microseconds. I really want to see that go under 1 microsecond. It'll never reach 0 because we're also including the round trip time to the database there. But I think let's just, to experiment, let's take the selecting 0 rows with trivial query, and let's specifically make sure that this gets used for the... let's make sure that this specifically can generate the type identifier so that we can skip SQL construction, even though the SQL construction here is absurdly simple. So let's go to the SQLite connection, and let's change this hash map. Let's create an enum. Where the key is either going to be SQL or type. And we'll need to derive hash and partial EQ and EQ. And then in prepare query, or in cached prepared statement, then what we're going to do here is what did I call that? Query ID. And then, yeah, it takes no arguments. This is gonna get real ugly. All right, we'll let this be ugly. In fact, I'm going to just duplicate. I'm not going to try and reuse any of this code right now. Maybe I... Because the thing is, we still need to construct the SQL if it's not already in the cache. Yeah, this is gonna get very ugly very quickly. All right. I'm going to let it just construct the SQL twice, and then we'll restructure this later. So then we need it to be query cache key type. Then I will just move this down here. And yes, in theory now I can use the entry API because I've got the SQL cloned, but that's not super helpful at this point in time. So I'll just make sure that compiles. Wait, did I say type? Oh, I said type ID. Whoops. Wait. Yeah, it compiled. Oh, I'm in the wrong tab. Yes, anyway, it compiled. Cool. So the type of this is going to be, well, here I can show you the full horrible long type signature of this. Probably should have let it finish compiling the diesel crate since it we still don't have incremental compilation. Anyone have any questions about like why we're doing this or what type ID does or anything like that? I'm trying to also, I've got the video preview up. I'm trying to figure out exactly how long the stream delay is. I think it's like at least 30 seconds. So sorry if I don't respond immediately. All right, so this is the actual signature there, and this is the very short version because it doesn't contain any special clauses. But the first element here is the first type parameter here is the native SQL type of the select statement. The second is the select clause, and the third is the from clause. And then there's a bunch of constraints that this has to be selectable from this and has to have be an expression of the same type as this. And when we get query fragment also cares about the backend, so we have there has to be the constraint that this SQL type actually is usable on that backend. I think that's all of the constraints that would apply to this because this is a pretty simple. Oh, and the select clause must be non-aggregate. Or rather, because it's a tuple, all of the elements of the tuple must be non-aggregate. You can select we've got a weird constraint. You can select a single aggregate expression right now, but you can't mix aggregate and non-aggregate expressions unless the non-aggregate part is part of the group by clause. This is part of why we don't have an API around group by clauses yet. And basically, the way I want to allow selecting, you can select a single aggregate expression, and I want to eventually allow selecting multiple aggregate expressions and then also mixing them if the non-aggregate part appears in the group by clause. But to do that, basically I need some form of negative reasoning because I need to be able to say that a tuple of two things is a valid expression if neither of them are aggregate or both of them are aggregate. And I need some way to represent that either non-aggregate is not implemented or that I have a trait called aggregate, which is mutually exclusive with non-aggregate. So, okay, anyway, let's go ahead and go into select statement. All right, so this is the first thing I'll need to override it. And Sorry, I've got other tabs now making noises that are distracting me. Okay, so we called it query ID. And we'll just assume that, oh crap. I can't actually call type ID here because I would need to, wait, can I? I don't think I can do this because I have no evidence that self is static because none of my type parameters have that constraint. Wait, so what's the constraint on type ID of again? Reflect. And the public API for that is any, I am assuming? Yes. Yeah, so for me to so I'd have to put the constraint that all of my type parameters implement any, which I don't want to do because they won't all implement any. So I need to come at this slightly differently. I need to change this to be like has static query ID, and then and this is where it's going to get really annoying because then I need to have type query ID any. And because default type parameters are not stable, that means that I will now have to go through and add this to every single AST node. Because what I want to have it do is like if this is going to return false, then what I want this to do is be empty tuple. Can I actually just opt in because we're on unstable right now, and I need this to work on stable? But yeah, can I just do that? Will that let me override it? Yes, Killer Cup. I am. My goal is to reduce the. Well, it's to both reduce the hashing work, and it is also to reduce the building the string is usually pretty cheap, but not necessarily free, because we still it'll basically compile down to string literal select plus string literal star plus string literal from plus string literal users, although it'll be more than that because it'll be the individual columns, right? And that's cheap, and it doesn't do a lot of expensive allocations or anything like that, but it's still linear time with the number of strings there, because while the buffer gets reused, it doesn't actually compile down to a string literal, right? We still end up doing the allocation and reallocation. So that's the part that I want to eliminate. And then, yes, I also will want to reduce the hashing work. yes, a perfect hashing function for that will further increase performance. I mean, heck, with a U64, I think even a B tree map might be able to be more performant than the hash map. That's sort of the secondary thing, though, and actually changing where the lookup occurs is pretty easy. Being able to actually get the correct type is harder. Okay, so now I need to... Right, and this is why I need to put it into a different trait, because box select statement is not going to use any of this. All right, so we're gonna go whole hog here, and we're gonna opt into specialization temporarily. Oh, I've already got it enabled up there. Not because we significantly use it, because like there's nothing in Diesel that relies on it to be sound, but there's a few things that that people want to be able to specialize downstream, and there's no way to do it without specialization. So boxed select statement is a special case of it where if you're in a web app or something and you have a search form and you need to conditionally change the query, you would need the type to be the same. So we end up boxing each of the individual components. And that one we definitely cannot statically get the type of at compile time. Okay, so let's break this into two traits, because we can't have these go together, because the query fragment needs to be boxed. And sure, we'll make it generic over the DB so I can put that constraint on it. There's no reason I need to put that constraint. Yeah, I'm going to do that for now, because to start, I'm going to do... And so I'm going to temporarily have this constraint on here, and I'm going to remove the super trait bound. So that way I can temporarily not have to go implement this for every AST node, even though I do need to implement this for every AST node. So here we can specialize. Oh, and here I would need to have the constraint. You know what? We're not dealing with anything other than where clauses right now, or anything other than basic queries, so I'm not going to specify everything. I just want to see if this even works remotely, and then we'll get into like doing the full proper implementations on everything. And here I will put on the constraints. I do not need to specify DB there. So DB is a backend. I don't care that DB is a backend. Where select statement implements any. And then in SQLite connection, that's all still fine. But this now needs to be query fragment plus query ID, which means prepare query is going to be plus query ID, which means query all is going to be, actually, do I even need to specify that? Is it smart enough to realize that because I have that blanket impl that one implies the other? I'm going to actually put use statements, but again, this is just me really, really roughly putting everything together. Oh, I'm sorry. I tried to put everything in the same window so I don't, or in different windows so that I can't accidentally switch back to my terminal, but I keep forgetting. What? How is that conflicting? Okay, let's try structuring this slightly differently. So that we can convince specialization that we are, in fact, more specific. How... Oh, I probably need to make them... I need to make them strictly overlap. So I need to say where... And then I can actually change that to be that. Sorry, I need to check. I need to just get in the habit of checking like the stream preview more often and checking chat more often. Any implies all of those things. I think I lost like 7 people when I forgot to turn my stream back. Okay. Has stack query IDs incompatible type for trait expected. Okay, and then over here, this is going to be. And actually, I guess I can leave that to be the same and instead have this be that. Because now we have this nice constraint of any in a place that's reasonable. Okay, let's see all the interesting ways in which it fails to compile now. Maybe I should just stop opening Chrome when I switch to docs, or switching the stream to Chrome. I feel like it's less interesting if I'm talking about all the docs I'm reading though, and that's not on screen. I need to get a second monitor is what I need, and not do this just from my laptop. I guess I could whip my other laptop out too. Oh wait, it compiled. Okay. And we're not doing any of the checking to, well, wait, aren't I supposed to, maybe it's just because, oh, it's probably because there's constraints other than the lifetime. Maybe. Is anybody here like super? Okay, well that got faster. So apparently we specialized on the lifetime, which seems wrong. Although maybe it's just because, oh, it's probably because there's constraints other than the lifetime. Maybe. Is anybody here like super familiar with the details of that? Maybe we can get Aaron to pop into the chat. Okay. So if I change this to be false, that should go up by double. And again, we're not expecting any of the other benchmarks to be faster right now because we've only specialized it for the super what am I trying to say? For the super super simple case. The medium complex one's more interesting to me, actually. Although I'm not sure also how much of that 24 microseconds is query builder versus versus round trip time to the database. Because this is definitely now, we can write a little micro benchmark for it too. That's 600 nanoseconds is definitely 100% round trip to the database / hash lookup. Yeah. Okay. So that's a difference. 400%. Now again, and I'm not right. So looking at this benchmark, or looking at this one, so we saved 1.5 microseconds, and then the next benchmark down is compared to 28.5 milliseconds. I'm not expecting that the query builder, like the query builder, is not a huge bottleneck for us. It will likely show some decent improvement there, just because allocation becomes a little bit actually it's probably going this is probably going to affect these cases a lot. When we have 10,000 rows, it's probably actually going to affect them a lot less than when we just added prepared statement caching in the first place, which even that affected those cases more than I wanted to. The query builder is not a bottleneck, right? In our worst case here, it's 24 microseconds. and we'll eliminate that entirely, and that's all well and good. I'm not expecting this to be now. Of course, the other thing to consider, right, is your average application is going to live probably somewhere closer to this than to this, because you're not normally sending 10,000 rows over the wire. You're getting 1 to 20. So I mean, it will be a non-trivial improvement, but the biggest thing is just because the idea of our query builder in practice being faster than a SQL string literal is just way too cool to pass up. So let's just see what the difference looks like if we don't do any special safety checking, and let's see what this looks like with that medium complex query. I say medium, and I call it medium complex because it's medium complex. It's nothing crazy, but you know, we got a join there, so we got 2 tables. We got some filters. We're using bind parameters. We have to serialize the bind parameters. Ordering. So the type of this one. Oh, and this is the boxed case. Where's the 0 rows? Here's the 0 rows. And the box case will not get faster. The box case will remain exactly the same speed. In fact, it will be trivially slower, but still the time. Well, right now it's going to be a lot slower because it's building the SQL twice. But anyway, what was I saying? Right, the type of this query, which will be much scarier than the already scarier than I would like type of the really simple select statement case. Hi, Jeff. Sorry, I'm having to send my wife like some screenshots of Twitch chat because like seeing, I don't know, Twitch emotes next to programming things just makes me giggle. Also, I like that my streaming software says it's using 20% of my CPU, and my activity monitor says it's using 150%. I mean, I know that's just 1 core being max versus all 8 cores being max, but yeah. Anyway, so this is the type of that. So you can see the type of this, even just the SQL type is now as long as the whole type signature was in the simpler case. So we've got 2. So right here, the first element of the tuple is yet another tuple, and this is all of the types of all of the columns in the users table. On the right side, we have, you'll notice we wrapped it in nullable, and that's because we're in a left outer join, so the right-hand side must be nullable. And then inside that nullable, you'll see each of the columns of the post table, right? And so then same thing. Our select clause got twice as long because we have all of the columns of the all of the columns from the users table followed by all of the columns from the post table. Our from clause now has also gotten longer. We have our left outer join source, presenting a join between those 2. No distinct clause, because that's where a distinct clause would go. And then our where clause here has the exact predicate that we've got. So it's an EQ node with the left-hand side as a column. The right-hand side is a bind parameter where the type is a nullable varchar and the value into it is a borrowed string. And so this is where we're going to get a little interesting, right? Because a bind param is, we don't care about this borrowed string. And I believe this is actually why the static constraint exists on any, because it's unclear whether the lifetime changing here should affect the type ID. And if it should, then that's impossible, basically. Is my understanding. I'm no expert on it. But right, and then we've got our order clause, which has the exact the whole point being that this is why this can work, is because our entire query is encoded in the type signature here. And that's also why the optimizer can, like, we're already competitive with just raw SQL. And like the assumptions we can make because we have all this information at compile time lets us skip a bunch of really like in really silly, stupid ways. We can skip a bunch of runtime checks that you would write if you were a sane person. But yes, that's why all of this can work, is because we have the entire query in the type. So, and in theory, we could somehow figure out a way to, I mean, ignoring boxing, in theory, we could probably actually generate the string literal from the type signature, but this is easier and less needing compiler plugins. Anyways, let's go back to that select statement. And what I think we can do here is, instead of having this static constraint on all of these, I think we can put the constraint where they all implement and I'm going to go ahead and do w query id db. Let's see, how far do we have to go? We didn't have to do the whole thing, right? We only had to go to order. So select from where do I do distinct first? I think I do distinct first. Distinct where group by and order. We're just going to ignore group by because group by is not actually supported yet. Right, and then the type can become select statement of the SQL types query ID and the select statements query ID and the from clauses query ID. Distincts query ID. Where is query ID? And offsets query ID. Okay, gonna answer chat really fast. What Vim plugin am I using to give those dots with indents? You mean just like the trailing dots here when I'm typing? That's not a plugin, that's just setting white space characters to visible in Vim. And yeah, the compiler's gonna tell me before I remember to check chat, because I check chat while things are compiling. Okay. So this will have to change to, this does not have to change right now. I'm thinking, like, for any of this to work, right? Of course, I need to have all of these be correct types and not empty tuple, because right now they're empty tuple. But I'm also realizing that we're still just in the, does this even work at all, and is it worthwhile from a performance point of view, stage. And in the benchmarks, we never run more than one query. So, yeah. We don't need these to actually be unique. And in fact, that should be enough to make it to make the benchmark demonstrate. Query Biddler. And I'm just gonna check in on Rails stuff really fast because I got a few pings. Make sure there's nothing I need to deal with. And everything is good. Wonder how many cores this video encoding is split over. Because, I mean, the compile time is just so much noticeably slower when I'm streaming. And the benchmarks even are running more than twice as slow as they do when I do it when I'm not streaming. But it says it's only using 17% of my CPU. Pro tip, if you want fast compile times, don't introduce types that cause a factorial time increase to your compile time with the size of tuples used in your program. I'm also very proud that I finally found a way to introduce a factorial time complexity algorithm into anything. Because the only thing I know of is basically permutations in an array. Oh, did it not hit it? Oh, that looks wrong. Oh, of course, I need to implement you know what we can do? Right, of course, because I have it returning false there, and that will return true. Okay, and if this works, if this number gets, like, small, I don't know how small, but if it gets small, then I will declare, okay, the performance seems fine, and then we'll go actually implement it for all of these types, and so we'll change this back to returning false, and then if that still works, I will remove the usage of specialization entirely, and then go do this for every other node. And then we'll add tests to make sure that a bind param, because bind param's the only thing that is going to implement query ID in an interesting way. I think that is true. And we'll do some tests to do things like, you know, I could just as easily write an implementation where the query ID type for and is a tuple, right? So we'll do something like binary nodes of different types, or different type IDs rather, stuff like that, and then make sure that bound is implemented properly. We don't actually need to write tests for things like trade objects don't implement it, because trade objects couldn't implement it with anything other than returning false or returning empty tuple. I guess we'll test that it returns false. Bind or column index out of range. Okay. I believe that means that we have a cache that is inflicting when it shouldn't be. What am I saying? This should still be able to return false. Yeah, we wouldn't need that. That wouldn't change the effect of this. So what am I missing here? This is what we're missing. I have the wrong type. There's no group by clause there. Group by comes after offset. Maybe I just implement this for everything in select statement and then have it just be type ID of empty tuple. Oh, here's where it's going to go wrong. No, that's not going to call select. We're never calling select. Especially not in this case. Let's also do this. Because we're so cheating. I really need to splat out the rest of the arguments in my script so that if I want to specify which benchmark to run. So somebody on Twitter brought up today that there are other streaming services that I guess are like meant for programmers, although I just picked Twitch because I didn't think about it at all, and to me, all streaming services are roughly the same. But if anybody has opinions on why one might be more preferable, please let me know, because I'm not tied to any single service. Oh, whoops. There we go. Okay, we are still not using our query ID. All right, here's what we'll do. Because I have a feeling I'm also just hitting weird cases in specialization that it's picking wrong implementations sometimes. I'm just going to remove all of those. And this is going to be... This is what it's actually evaluating to at the moment. 1, 2, 3, 4, 5, 6, 7, 8, 9. Awkward stream silence. That's funny. On Twitter, people there's just been like a little thread going about among programmers, just about like first date ideas. And I always recommend coffee because it can be really short if it doesn't go well. Whenever I mention like coffee dates, it always just makes me think about when my wife and I had our first date. We went and got coffee, and I totally knew we were gonna get married like after our first date, which is, you know, kind of cute now that we've been married for several years, and absurdly creepy if I had told her that on the second date. Okay. Okay, I think we have to do this for real and not like, and not cheat. Well, okay. I'm just trying to figure out though. Like, where is it actually doing more than one select statement? Are we actually just legitimately binding wrong? Because the binds happen up here. So that's fine. Unless it's like... in connection. So I call schema connection. Calls connection without transaction. That establishes it, and that runs the migrations, but those are not going to get cached ever, because those are going to be calling batch execute, which doesn't go through the cache. Begin test transaction unwrap. Well, and we would see that in the stack trace. So I really don't want to have to go implement this for every AST node just to see if it makes that one case slightly faster. I mean, it will, but that's just really annoying. No, that's not... Oh, right, the migrations are, the migrations are generating a thing. Okay, so let's... Yeah, because the migrations do, like, use diesel for inserting and things like that. Okay, so here's what we'll do. So we don't have to implement this for every AST node, but we do need to implement it for 6. Plus some tuples. A little bit more than 6. That's fine. You know what? This will give a good sense of, like, some of the more mundane stuff. Anyway. Right, so we'll go back to having that where st implements query ID. So this will be st query ID. Okay, and this actually needs to be this. And I'm not going to be able to turn this into an editor macro, so that's going to be really annoying. Okay, so the first thing we need to do is column, SQL, well, okay, so SQL types. I almost don't even want to do this for SQL types. SQL types are always going to be whatever. This is a mess of how I avoid having to write has SQL type over and over and over again, but this always gets called, so and the reason this is also like double colony and dollar signy is because I intend for this macro to be called from other crates. And yeah, I can assume that this is always static and implements any. And then tuples, I'll just put that here. And for those of you macro fans out there who are getting very frustrated that I put the comma here and not here because that will put the trailing comma, that is because this will get called for single element tuples, and if I don't have the extra trailing comma, it will treat this as a type alias for t and not as a tuple containing exactly t. And this is the wrong place for that. That looks correct. Has static. And this one's fun. You would think that with macro expansion, it lets you put any character as the joining between them, but it's actually a limited subset. It's not because it's two characters, because like you can put double colon there and that works fine, but you can't put double ampersand there. So instead, I have to do and true at the end. Okay, so now I've got tuples. We need columns. Actually, because I haven't looked at other screens. First, I'm going to make sure I don't have documentation up. Okay, good. Chat. Sound quality is really bad. Is it better if I sit closer to my microphone? Okay, so we've got tuples, SQL types, columns. We need to do it for tables. Am I using Query Builder? I am using Query Builder star. Okay. Weird static when I speak. All right, hold on. Let me. All right, you know what? I'm going to just do a quick audio test and see if restarting the stream helps. So I will be right back.